The Foothill Gold Line is a 24-mile extension of the Metro Gold Line light rail system that currently runs between Los Angeles and Pasadena. The Foothill Gold Line will extend light rail service further east along the foothills of the San Gabriel Valley and is being built in 2 segments. The first segment is under construction today and will add 6 new stations in Arcadia, Monrovia, DeWerde, Irwindale, and Azusa. A second segment from Azusa to Montclair is undergoing final design and seeking construction funding. Paramount to this important light rail project is construction of the light rail track system itself. Built in layers using both people and machine power, the track system is a synergy between state-of-the-art communications and safety systems with good old-fashioned concrete, steel, and rock. Together, they create a durable, reliable, and very precise backbone of the light rail line, one that provides for the safety and comfort for future riders. In this video, we'll show you the numerous steps involved in building the track system for the Foothill Gold Line and how it gets done. To start, work begins underground. Under the tracks are extensive drainage channels and duct banks that run the entire length of the corridor. The drainage ensures that rainwater is removed from the track area, and the duct system carries hundreds of miles of conduit for state-of-the-art communications, train control, and traction electrification systems. Also underground are hundreds of foundations needed to support the overhead catenary system poles, which are part of the electric power system for the light rail line. Once the underground work is complete, work above ground starts with filling in the uneven valleys, cuts, and high points of the earth with small crushed rock called subballast. This is done to create an impermeable surface that directs water to the drainage channels. A 12-inch layer of ballast, or larger crushed rock, is then placed and roller compacted above the subballast. Together, these layers provide a uniform foundation for the track. The track itself is made up of evenly spaced concrete rail ties and continuously welded steel rails. The concrete ties are placed on top of the ballast by a machine nicknamed the Tie Dragon, which is able to easily and efficiently space the ties 6 at a time, exactly 30 inches apart. Then, a pair of steel rails is brought in. They arrive in 800-foot segments that get welded together on site to make one continuous smooth riding surface. They are placed on top of the concrete ties and then permanently connected together using metal pieces called E-clips. 4 E-clips are used to hold the 2 rails onto each concrete tie. Once the rails and ties are in place, it gets flooded with more ballast. Covering the tracks with ballast helps to restrain the track system so that there is no movement under traffic or changes in temperature. Afterwards, the Mark IV tamping machine is brought in to adjust the horizontal alignment and elevation of the track to its final position. It does this by picking up each tie and compacting the ballast beneath it until it is at exactly the right height. Everything is adjusted according to very strict and tight tolerances to meet safety and comfort criteria for future riders. Finally, the electric power system is installed, made up of the poles, OCS conductors, cabling, and traction power substations. This is a critical last step that will provide the power to the light rail trains. As you recall, concrete foundations were built underground during the first phase of work, each about 200 feet apart. Now, steel poles are installed onto each of these foundations. Each pole weighs about 1,200 pounds and is installed using cranes. Next, a team of electrical experts installs the power distribution wiring onto the poles. First, the messenger wire is installed at the top, and then the contact wire below. The contact wire is the wire that the light rail train's pantograph system comes into contact with to transfer power to each vehicle as it travels along the track. As part of the electric system, traction power substations are installed about every mile to convert the electricity provided by the local utility company into the form used to power the trains. Although many more elements are involved in completing the entire light rail system, these are the major steps that prepare the track itself. As you can tell, this is a specialized process done by a team of workers devoted to this particular element of the project. In fact, once done, these workers and machines move on to other projects around the country. We thank them for their dedication to excellence. For more information on the Foothill Gold Line, or to watch other videos produced about the project, please visit www.foothillgoldline.org.